It's actually a nice coincidence that I can talk after Antonio from Kilt, because we are kind of doing the counterpart. So now you learned how you can bring your identity from one chain to the other chain. And what I'll be talking about is how can you bring some information from one chain to the other chain without revealing your identity. So instead of linking, what we want to do is unlink. So it's a complementary part. And that will be, you will see a demo about how that actually happens. So let's take a fictional use case. We have information on one chain, which in this example is Encointer, and the information is personhood. So you just know that someone is a real person and associated to only one account. So on the other side, we have, for example, the frequency blockchain, but it could be Kilt just as well, Sub0 or any other chain interested in personhood information. And on top of frequency, you have, for example, the MeWe social network. And a social network has a benefit if you know that one person can only have one account on that network, or at least one account with this proof of personhood, because that helps you defend against all kinds of Sybil attacks. So the use case of what we want to do is we want to take personhood information from one chain and bring it to another chain, but in a way which is privacy preserving. Because the problem is, if you have this unique person badge on MeWe and your information is linkable, then all your on-chain activities will be linkable. And for example, you can look up what the balance is on Encointer from that person. Not only the balance, but the spending behavior, all kinds of things that you don't really want to expose just because you have a profile on MeWe. Or especially not if you have a profile on MeWe. Because there you might reveal your real name, which you didn't over here. And this information we really need to keep separate. So the Polkadot ecosystem has a very nice and unique feature called XCM, cross-chain messaging, which could actually provide this use case in various ways. But let me go into the first way, which is really horizontal message passing. So the user would initiate an XCM transaction on the Encointer chain, which would go through the Kusama relay chain, because it's even cross consensus here, because Encointer is on Kusama and frequency is on Polkadot. It would go through the bridge hubs and then invoke a state transition on that side to get this nice batch. Now, this is one way how you could do it, but I want to argue that even if you don't use anything of integrity, that it's not the right way to do it. Actually, if you just need state transition to happen on one of the chains, then you should work with storage proofs. Then you shouldn't actually send XCM messages across all of those hops. What you should do is the user gathers a storage proof on Encointer, commits that proof over here. You actually presented it nicely before, why that is a nice use case. And then you just evaluate that storage proof on the other side. That is a lot cheaper than going through all those horizontal message passing ways. However, it still doesn't fulfill our use case, because we want it to be unlinkable, and this is still linkable. If you have a storage proof on that side, you can still link it back to the origin, and you still have linked information which you would have liked to be separate. So here enter Integritee with a way how you can unlink cross-chain message passing even across different consensus system. The only requirement that we currently have is that you are connecting two substrate-based chains. But that's purely, I mean, this can be circumvented as well, but our SDK just offers this now, and I will demonstrate it. So the idea is the following. You have a trusted execution environment. I will talk in a minute about what that is and why it is cool. This trusted execution environment has light clients into all those 3 chains, and it can send extrinsics to all those 3 chains. That means it can verify storage proofs, and it can initiate state transitions. So in the case of Encointer, what is it going to do? Your user opens a TLS connection with the Oracle and says, you know what, my account on Encointer is this one, my reputation on personhood is this, here are the proofs, and my account on the frequency side is another one. And because the TE can process this information confidentially, and because you have a TLS connection to the TE, this linkable information will stay invisible to the outside, even to the operator of the TE. So the idea really is we prove something to the TE, and then the TE will sign an extrinsic on our behalf, which will award personhood on the frequency side. Now, this sounds a little bit too good to be true, right? Because why would frequency accept this extrinsic? Anyone could send it. So we need a way of whitelisting who may send these kinds of proofs. And that's where the integrity chain comes in. But first, let me just give you a very, very rough idea of what TEs are for all those who are not familiar with it. TEs are a hardware feature which guarantees that a certain process is executed confidentially and with integrity. So you can be sure that a specific software has been executed, measured by the hash of the software. So if you have deterministic build, you can really be sure that a certain source code corresponds to what is running on that service. And it is run confidentially, even so, and this is actually the novelty, or one of the main novelties here. You are all used to having IT admins who see everything. So they can, they are not allowed to, but they could read your emails. And if maybe today you are with Microsoft, and they cannot, but then at least Microsoft can, or the admins of Microsoft can. So the key here is not even that we distrust the admin, but we accept that everything can be hacked. And the problem is, if we execute something and we trust the admin, and some malware can enter the system and augment its privileges, it can do exactly the same what the admin can do as well. But not with TEs. With TEs, you can execute a certain service, and malware cannot change what is executed, and it cannot see the data which is processed. And so the technology that we are using is Intel SGX, not because we are particularly fond of all the policies in how they do it, but they are the only TE technology which provides remote attestation. And I want to walk you through the cycle of trust if you work with TEs. So it all starts with the code. If the code is crap in, crap out. If the code is not preserving privacy, then neither will the TE. So we start here, and we can audit that code, have it audited by third parties maybe. But then what we need to do is we need to release that software. We need to build a binary which is executable. And here it is essential that this build is a deterministic build, because then we have a strict relationship between code and the binary and the hash of the binary. then we can execute it on a machine which has the Intel SGX feature, which is all the Intel servers currently. And you don't need to trust the operator of that machine to actually execute the right software. But now comes the critical thing, and here is one of the main value adds of the Integritee network. The problem is, you need now to remote attest what is running here, because how would the user know that what is executed here? And that's the process of remote attestation. If I let you execute my code, how do you convince me that it is actually my code that you are running? So there is Intel attestation services. They can do that for you as a service. Data centers provide that as well. But we have a vision here in Web3, which is unstoppability. And we don't want Intel to be in the power to censor use cases. So if we use their remote attestation stuff, then the problem is that they could say, oh, the hash of your software is this. We have blacklisted that software. It is illegal. We will not give you any remote attestation. So here enter the Integritee network, because we do the entire remote attestation process on our public chain. Actually, this is called the decap process, which was initially meant, so Intel developed this such that data centers who are not Intel can provide remote attestation on behalf of Intel. And we take it one step further and we say, you know what, we even cut the data center out of this chain, so you can send whatever proof the TE creates directly to our chain where it is verified. And this is now closing the trust loop in the entire story, because now the user can look up on the chain if the service that they are talking to is indeed running the software that they think it is running, and if it is running on a genuine SGX machine. So now the user can open a TLS connection to that TE, and the certificate, the TLS, well, it could be HTTPS, whatever, WebSocket, the certificate from that side will be signed with the key, which you can look up on the Integritee network. Okay, so that was a little excursus on the matter of TE, but now back to cross-chain messaging. So I just want to quickly compare the two. XCM will be forever linkable with the chain history, whereas the TE bridging that we present is unlinkable under certain assumptions, of course. One of the assumptions, or one of the guarantees, is just K anonymity. Because if you're the only one who ever sent a message over that bridge, well, then you're linkable, obviously. XCM is so far consensus internal, or you need an established bridge between the two if you want to use it, which we will hopefully see very soon between DOT and KSM. On the other side, obviously you have to trust the design of a TE, because it's a hardware feature. It can have flaws, and it did have vulnerabilities in the past, which are always kind of kept up with from side of Intel, but we need to accept that this kind of things can happen. And one more important difference is you do not need a HRMP channel established. That's kind of, so if you need an HRMP channel, both chains need to accept. One proposes, the other accepts. With our proposal, you don't have this. You don't need, neither of the chains needs to say yes, because everybody can read this chain and everybody can write into that chain. So there is complete agility in terms of cross-chain messaging. Okay, so now I just want to show you a demo, and this is what you're going to see. So you will see the Encointer chain, the Integritee chain, and a node template. So we didn't take frequency or kilt or whatever. It's just really a very simple node template, and the extrinsic which will be executed is the do something with an ID. So you can imagine that you pick an ID that you want to be associated with you, which is just an integer number. But in the end, accounts are all integer numbers, just with a few more bits. All right, so you will see how we create proof of personhood. It will be evaluated and it will be committed on the node template side. So now I would ask production to start the video. Exactly. So we start with the Integritee node, then the Encointer node. We are starting them all up. The substrate node template, and finally the Integritee SDK-based personhood oracle, we call it. And this personhood oracle will now start up, and it will start by sending an extrinsic to the Integritee node, register SGX enclave, and it needs to provide remote attestation in order to be included. And now all the oracle does, it listens to events on all those three chains, and it acts on certain events. So here we already see Alice has tried to obtain personhood proof, but she doesn't have any reputation, so it failed. I'm sorry, I should talk a bit faster. So what happens now, we have Alice, Bob, and Charlie performing the Encointer protocol. So they register their community, they attend a personal key signing event, and then they will get 3 times the Encointer basic income and 3 times proof of personhood. So now Alice can try again. And you see she picks the number 42 as her identity, and this time it works. So we see that the something stored event has been thrown. That means the extrinsic on the node template has actually taken place. Now, obviously, we didn't involve any whitelisting here. That goes beyond the scope of this demo. And we want to show that Bob can do the same, picks a different number, and again, something stored. But now if Ferdy tries it, Ferdy doesn't have any reputation, any personhood reputation on Encointer, picks his number, and it will fail. And there is an entire additional story here, because we also need to make sure that Alice cannot claim 2 numbers, but that goes beyond the scope. Encointer has a solution for that, but for this talk, it is out of scope. Okay, so that basically is the end of the demo. All I want to add now is, like, how can you build this stuff? Because Integritee, it is an exception that Integritee actually builds the use cases, because we want to provide the SDK, we want to provide the primitives for you to build on it. So that's why already last year we published the sidechain SDK and the Oracle framework. So you can, with our SDK, you can either build second layer technology for scalability, for privacy, for interoperability, for whatever you want to use it. The Oracle framework just allows you to bridge Web 2 content into Web 3, like, for example, exchange rates of your favorite token. And this is in production as well since March. And if you don't have a TE, you need to rent it somewhere. And if you rent it with the cloud providers that are around, you still need to worry about a lot of stuff. So we have simplified that for you. We actually provide a subscription service where you can just order a Kubernetes cluster of TEs for your use case. And our very new announcement in August is the attestation service. That was what I was talking to on kind of the full circle trust, that you can do decap on our network. And the attestier specifically is a service which acts as a proxy to our network. Because all you need to do to get remote attestation now is produce a quote and send it to our REST API, and the attestier will forward it to the chain. So you don't actually need to integrate anything in your solutions which are based on TEs. So it can be Web 2 solutions, but you can still benefit from the remote attestation on our network. All right, that does conclude my talk, and I'm looking forward to your questions.
Does anyone have any questions for Alain? Yep, give me a sec.
Yeah, thank you very much for your talk. So my question is, what measures are in place to ensure security and reliability of TE-based solutions in cross-chain messaging, especially when dealing with sensitive data?
Sorry, I didn't get the beginning of your question. What security measures are in place?
Yeah, to ensure security and reliability of TE-based solutions.
Okay, okay. So the security aspect of it is what we are actually using from Intel SGX, right? We are not TE engineers. We use TE as a tool. So you need to accept the security model which comes with Intel SGX currently if you use our solution. However, there is more to it because it's not only about security, it's also about availability, I guess, because you want to have a service. So what we can provide with our SDK is that you can replicate, that you can have redundancy, and with shared secrets even. So you can, for example, if you have a use case which needs, which is stateful, which needs to access confidential data, then you can have rules on, for example, only exactly the same fingerprint of software can access that data, and we can make sure that the encryption key is provisioned to everyone who is using that software, running that software, so we can get an unpermissioned access to running this infrastructure. And you can, for availability reasons, you yourself as kind of a DApp developer, you will want to make sure that there is a minimum amount of infrastructure there to provide availability. But basically, it is your choice if it will be an unpermissioned set or a permissioned set of a certain size. If there are incentives, that's for you to decide. We don't mess with incentive systems. If you want to have remote attestation, you need the tier token. But whatever you do on your second layer, that's your decision and your kind of security design of your use case. Does that answer your question? Thank you.
Any other questions? Okay, thank you very much, Alain, and
Thank
I'll see
you
you around.